Welcome to another JPJ Discovery video. A radio galaxy is a type of galaxy with giant regions of radio emissions that reach far beyond its visible structure. A radio galaxy is an active galactic nucleus, AGN, that emits a significant amount of energy in the radio wavelengths, typically from its core and two large lobes of high-energy particles and gas located outside the visible galaxy. These intense radio emissions originate from vast lobes of gas that extend well beyond the galaxy's visible structure, often spanning millions of light-years. Typically appearing in pairs, these radio lobes form when the galaxy's core contains an active galactic nucleus, AGN. This extremely luminous region is powered by a supermassive black hole, superheating and feeding on the surrounding material, causing the galaxy to radiate brightly. Around 15% to 20% of galaxies with AGNs are bright in radio waves and are classed as being radio loud, according to the California Institute of Technology, Caltech. Quite what makes one AGN radio loud and another radio quiet is not currently fully understood, as the emissions of other wavelengths of light from ultraviolet to X-rays are similar from both types of AGNs. Some research suggests radio loudness may be connected to host galaxy type, with radio galaxies almost exclusively taking the form of giant elliptical galaxies. These galaxies could be created by the merger of two smaller galaxies. Radio emissions could also be connected to the rotation of the central black hole, which may facilitate the formation of powerful jets. Famous examples of radio galaxies include Cygnus A, with a bright radio source that consists of two bright lobes of billowing gas and dust on either side of a galactic nucleus, Messier 87, with twin jets extending from a bright nucleus, and Centaurus A, an elliptical galaxy intersected by a lane of dust. There are two distinct types of radio galaxies defined by differences in their optical emissions. Broadline radio galaxies show broadline light emissions from ionized oxygen, hydrogen, and silicon in their optical spectrum. Narrowline radio galaxies are AGNs that lack broadline emissions, but have narrow emission lines from hydrogen and triply ionized oxygen. Many galaxies like ours don't have AGNs, which are powered by feeding supermassive black holes, but even those that do are not necessarily blasting out radio waves or radio loud. It is only these AGNs that are defined as radio galaxies. The discovery of radio galaxies occurred in the late 1930s and early 1940s, when radar operators during the Second World War accidentally started to pick them up. It would take another 10 years to better understand what had been discovered as the practice of radio astronomy burgeoned. The first radio galaxy ever detected was Cygnus A, discovered by one of the pioneers of radio astronomy, Grote Reber, in 1939, a featureless oval elliptical galaxy of the same name located around 500 million light-years away, according to Britannica. It remains one of the closest and brightest radio galaxies ever discovered. Radio galaxies tends to be the term given to galaxies with large jets coming from their centers, but the crucial additional element in understanding their connection to mergers involves what's called their excitation level. If the radio galaxy is a high excitation radio galaxy, it is shining brightly in ways that are independent of the jet, and this might be due to a recent merger. There are low excitation radio galaxies too, which on the other hand are likely very old galaxies where relatively little material is falling into the black hole and no merger signatures are visible. These objects were likely triggered by mergers but looked very different at that time and have evolved over characteristic timescales of billions of years to become these low excitation objects with jets.